Hello everyone, you're watching lesson video 6.4. We're going to talk about stretching parabolas, and my dogs are probably going to bark in the background, so I already apologize. First, I want you guys to do a quick review of what it means. Up at the top here, I wrote this in. What does A do to the shape of a parabola? And I think you might remember this. The first part of the notes here is also going to help you remember this. What does A do to anything? So you could also be thinking, why? Oh, my pencil's looking. Hold on a second. You could also be thinking y equals a in front of an absolute value graph. So we had the v graph, and then we put an a in front of it, and we played around with what the shape of the graph did. And I think you'll start to remember things from earlier in the year. We're also going to revisit completing the square. It's going to be a little bit harder than we did, so a bit more work with completing the square. This a is the leading coefficient that we're going to be talking about. That's important. You should highlight that. Let's understand what A really does when you're looking at the quadratic here in standard form. So far, we know that if A is positive, the parabola opens upward. And if A is negative, it opens downward. And you probably, if you're in my class, you've seen me write this before. A is positive, it opens upwards. I call her Pretty Minnie. A is negative, it opens downwards. I call him Mad Max, because this is a minimum and this is a maximum. So let's see if you can deepen that understanding. There they go. I knew they'd bark at you. Using the calculator if necessary, sketch and label these graphs. So I've already done this. Why don't you guys shut the video off and then restart it after you've graphed these things. Or I'm going to do that and then turn it back on and show you what I came up with. Okay, so you're looking at my graphing calculator now, and you can see x squared, 2x squared, and 4x squared. And you can see that each time I graphed, the graph got a little bit steeper. So x squared, these are just going to be quick sketches. X squared, and then 2x squared got a little steeper, and then a 4x squared got even steeper. So it's called a vertical stretch, and the number gets bigger. So when we're multiplying x squared by a, we have a vertical stretch. Vertical stretch. The graph gets steeper, like a steeper slope. Also, that's because the a here was whole, and it was greater than 1. Keep that in mind because I'm going to talk about a fraction in a second. So vertical stretch, steeper slope. Some people also will use the word narrower as opposed to what happens if a was a fraction. If that a value was like a 1/2, for example, then the graph would have gotten wider, and it would have looked more like this. And you can graph that to see a much better parabola than what I just sketched. So 1/2 x squared would actually be wider. My dog is going crazy because she's watching people shovel outside. Wider, you could say less steep. Oh, that's not enough s's in there. Less steep. Or you could also say, going back to the vertical stretch thing, you call that a vertical shrink, because it's like it's shrinking down to the x-axis. No, shrink. I'm having a hard time focusing with all my noise in the background here. I hope you guys are able to do this better than me. So vertical shrink. So A stretches and compresses a parabola depending on whether it is greater than 1 or between 0 and 1. That would be like a fraction. That would be like a 4. And that should sound familiar to you. Okay, so take a minute and match these equations with the graph over there, and then I will show you the answers to that in just 1 second. You take a minute to think about it. Okay, so when I did this, I looked at the ones that were negative first, and numbers 3 and 5 were negative, so I knew those were the upside down ones. The -2 was the steeper or narrower one, so there's where the 3 went down here on that parabola. And then the 5 was a little bit wider. It was the standard, regular, normal, negative x squared. Then I looked at the ones that were positive, so choice 1 and 4 and 2, and I said 1 would be the steepest, 4 would be the normal one, and 2 would be a little bit wider. Perfect. Nice little bark there. Okay, so on the next page, we're going to get into Oh, I clicked the wrong page. I have extra pages that you guys don't have, so let me find out where we're supposed to be here. Okay, so next page should be this page. All quadratics of the form y equals ax squared have their turning points at the origin, and we can identify the points. If we place it in vertex form, we can identify the points of the vertex, of the turning point, even if a doesn't equal 1. So this is going to be completing the square, but notice that I highlighted the 2 in the front. Throughout my page, I highlighted that the a is not going to be 1. So using the method of completing the square, write this equation in the vertex form. So you're going to do the same process that we did in our last notes. 2x squared minus 12x plus blank plus 11. You're going to have to factor that 2 out and pull that to the front, because if you look, that's where it'll be sitting. So pull the 2 out of these 2 pieces. It's going to move some parentheses here. So we're going to have an x squared minus 6x plus blank. Just still leave the 11 alone. So the completing the square is going to go on inside these parentheses. So you're going to take half of the negative 6. So we have an x and an x. We're factoring this. Minus 3, split that into 2 equal pieces, splitting up the b. And then that was a 9 if you multiply them back together. Negative 3 times negative 3 is a positive 9. The trick is that that 9 is actually doubled because it's got a 2 in the front if we were to redistribute it. So we just added in a 9, but it was actually an 18, and we got to take off an 18. So when you put all this back together, you have a 2 in the front. Your perfect square is x minus 3 squared. And on the outside here, positive 11, take away 18 is negative 7. So the 2 doesn't affect the vertex. The vertex is positive 3, negative 7. The 2 just means it's positive, so we know it's upright, and we know it's going to be a little bit narrower than a regular x squared. So part B asked me what are the coordinates of the vertex, or the turning point. I already said 3, negative 7. And if you looked at your calculator, you would graph this, and you would see that there is a minimum at 3, negative 7. So we could graph 2x squared minus 12x plus 11. So if I go and do tab and enter a new equation here. Oh, my calculator's acting funny. All right, I'm not going to do that. So you could do that on your own time with your own graph and check that out. Let's do more completing the squares and identifying the turning point when there's an a in the front. So let's take out that 5 again. 5. I'm just taking it out as a GCF, and I'm only taking it out of the 2 things that I'm completing the square on. So I'm dividing this by 5 and this by 5. So that's a 4x plus blank, and there's my 23. Now I'm going to try to complete the square on what's inside these parentheses. Oh, I lost my x squared there. There he is. Okay, so we have x and x, and we have 2 and 2. I'm splitting the b in half, positive, positive. That actually created a positive 4 when I multiply them back out, and that 4 is really a 20. So take off 20. So we have a 5. We have an x plus 2 perfect square, and we have a 23, take away 20 is a positive 3. I know I'm doing this kind of fast, but you can always slow down, replay, rewind, do whatever you got to do to figure out what's going on. Identify the turning point. Okay, so the turning point would be negative 2, 3. And it also wants to know, is that a maximum or a minimum? So since this a value is positive, I'm going to say that's a pretty mini. So that's a minimum at negative 2, 3. Next, let's do this again. So notice there's a negative 2 in there. You cannot complete the square with a 2 right there. You have to divide it out front. You have to take it out as a GCF. Negative 2, positive 7, move over to the other side, just out of the way. If I take a negative 2 out of each of these pieces, I get x squared minus 2x and a blank. So I have negative 2, start factoring this. x minus 1, split that into 2 equal pieces. Multiplying -1 times -1 means I got to put a +1 in here. That's actually a -2. Okay, so that -1 gave me a +1. When I multiply it to -2, a -2 that just got put in means I need to add on a 2. So there's a little bit of a trick to that. Also, that sign right here was a little bit of a trick, so keep an eye on these little things, maybe replay and make sure you know where they're coming from. -2, x minus 1 squared, and then 7 plus 2 is 9. So my vertex, oops, I don't know why I'm writing another y equals. My vertex is at, just looking at the 1 and the 9, change the sign on the 1, don't change the sign on the 9. And since A was negative, that looks like Mad Max, and it's a maximum, meaning that'll be the highest point on the parabola. That turning point will be the highest point. All right, let's look at this one. We're going to take the 6 out of these 2 pieces and move the 14 away a little bit. So when you pull the 6 out, like a GCF, you get x squared minus 4x plus blank. There's my 14. He was positive. All right, let's start factoring what's inside these parentheses. X and x, minus 2 minus 2. I just split the -4 in half. That's a +4 that I need inside, which is actually a 24. That's a trick. Don't lose the +24. I don't know why I just wrote 12. I'm losing my mind. So I'm going to take off a 24. 14 take away 24 is -10. So I have y equals 6 with an x minus 2 on my square and a -10. The vertex is at, change the sign 2, don't change the sign -10. And since the 6 over here is a positive number, that's a minimum. It's a low point on the parabola. Okay, this one you're just taking out a negative, so you can never have anything in front of the x squared. Even if it's a -1, you have to factor it out. So I'm going to pull a -1 out front. There's my -33. I'm not messing with him. Dividing by -1 gives me x squared, a positive 12x, and there's the blank. Take half of 12, so -1, x and x. I'm trying to factor this stuff. Take half of 12, 6 and 6. That's a 36. But it's actually a -36. If that's a -36 that I just put in, I got to add a 36. And when I add 33 and 36 with a negative and a positive here, I get a +3. So -1, x plus 6 squared plus 3. The vertex is at -6, 3. Change the sign on the 6, not the 3. And since A is a negative, that will be a mad maximum. So it wanted you to write it in vertex form. It wanted the vertex, and is it a min or a max?